So surface tension, imagine you have a beaker in your hand. Okay, beaker को अगर ऊपर से देखोगे, so you will see a circular cross section like this, correct? And in this circular cross section, समझ लो मैंने ये पूरा एरिया सरफेस है व्हाट लिक्विड का, इधर मैंने इमेजिनरी लाइन ड्रॉ किया. आई हैव ड्रॉन एन इमेजिनरी लाइन ऑन दैट सरफेस. अब ये लाइन के ऊपर ऑब्वियसली फोर्सेस है जो खींच रहे, ओके, मॉलिक्यूल्स को. सो लेट अस कंसीडर दीस आर दोस फोर्सेस. These are those forces which are stretching, okay, this membrane. Clear? Now this force divided by the length of this line, imaginary line, that is what is the formula for surface tension. So you can see over here, surface tension is denoted by letter capital T, which is equal to this forces, which is called as tangential force, divided by the length of the imaginary line drawn to the surface of the liquid. You can very well see the definition. It is tangential force per unit length on both sides, okay, both sides, and drawn to the free surface of the liquid. This becomes the definition of surface tension. Let's talk about units. This can be having unit as Newton per meter. Agreed? एक और यूनिट बन सकता है इसका. लेट मी डिराइव इट. अभी मैं क्या कर रहा हूं, आई मल्टीप्लाई मीटर ऑन बोथ साइड्स, न्यूमरेटर एज वेल एज डिनोमिनेटर. इधर भी मीटर, इधर भी मीटर. सो दिस विल बिकम न्यूटन मीटर डिवाइडेड बाय मीटर स्क्वायर. नाउ चेक दिस, न्यूटन मीटर ये जूल है, करेक्ट? फोर्स इनटू डिस्प्लेसमेंट. दिस इज द यूनिट ऑफ वर्क, दैट इज जूल. So इसके बदले में जूल भी लिख सकता हूँ, divided by meter square. So from this what we conclude, surface tension has two units. One is Newton per meter and second one is joule per meter square. Clear with this? So surface tension is a topic in which we are going to study some derivations. One very important derivation I'm just going to start right now. Okay, let me rub this. This is just a definition which you can find it in your textbook. Our next derivation is regarding surface energy related to surface tension and the change in surface area. So to understand this derivation, first of all you need some basics to understand what is surface energy and what is the surface area. Okay, surface tension is so interesting topic that you will relate this in your day-to-day life. Like I'll give you example of spider. कल भी दिया था. Spiders के example में क्या समझा? Like एक layer बन जाता है which is not broken easily by spider. So वो layer के ऊपर spiders walk कर सकते हैं. First thing. Secondly, you observe like needle. Okay, if you gently place it on the layer, then definitely needle will float. Clear? Third example, mosquito eggs. Mosquito eggs अगर water में रखोगे, ठीक है, तो float करेगा. But वही water में अगर आप केरोसिन डाल दोगे, तो केरोसिन क्या करेगा? सरफेस टेंशन डिक्रीज करेगा. सरफेस टेंशन डिक्रीज हो गया मतलब वो बॉन्डिंग टूट गया वाटर मॉलिक्यूल्स के बीच में. ओके, सो नाउ मॉस्किटो एग्स विल गो इनसाइड. ओके, नीडल के साथ भी ऐसे ही होगा. नीडल के ऊपर प्रेशर अप्लाई करोगे तो बॉन्ड टूट जाएगा एंड नीडल विल गो इनसाइड. वॉशिंग क्लोथ्स, ओके, वी यूज डिटर्जेंट. सो व्हाई वी यूज डिटर्जेंट? उसमें भी यही इशू है दैट व्हेन वी यूज डिटर्जेंट, ओके, सरफेस टेंशन इज रिड्यूस्ड. And since surface tension is reduced, what happens? Molecules are free. Water molecules free है, bonding टूट गया है. So now water molecules can reach corners of the clothes and वहां से dirt को निकाल सकते हैं. Okay, so detergent decreases surface tension. One more thing I'll tell you. If I ask you clothes wash करना है, is cold water better or hot water better? Boys won't be answering, but girls knew it. Hot water is always better for washing clothes. So what happens in this case? With increasing temperature, surface tension decreases. Okay, so hot water is preferable because temperature ज़्यादा होगा तो surface tension कम. Surface tension decrease हुआ मतलब bonding टूट गया. Water molecules free है corners तक जाने के लिए, शर्ट के, क्लोथ्स के, जीन्स के, and they can easily remove the dirt. Is it clear? So this is one more interesting example of our day-to-day life. Then we can understand concept of meniscus also. Let us consider this is our tube, टेस्ट ट्यूब. इसमें अगर वाटर फिल किया है तो वाटर का मेनिस्कस यू नो इट इज समथिंग लाइक दिस, ऐसा बेंड होता है नीचे. सो व्हाई इट इज बेंड? फर्स्ट ऑफ ऑल ऑब्वियसली यहाँ पर कॉर्नर्स में देखोगे तो अधेसिव फोर्सेस रहेगा, बिकॉज ऑफ दैट इट इज बीन पुल्ड. ओके, सो इट राइजेस ओवर देयर. अब यही अगर आपने मर्क्यूरी के साथ किया होता, द सेम थिंग if you would have done with mercury. So mercury में meniscus कैसा बनेगा? It will be something like this. Okay, it will be this way. Let me tell you, this is called as concave meniscus. Concave meniscus, and this will be called as convex meniscus. This is for water and this is for mercury. अब इधर ऐसा क्यों बना? Because mercury में adhesive forces नहीं है, cohesive force ही है. So इधर वो bonding test tube के साथ नहीं बना सकता. It can make bonding with own mercury molecules. So this is also one of the interesting examples where you can easily observe this concept of surface tension. Then there's one more example about rinsing in mouth. Early morning जब brush करते हो and once you are done with your brushing, फिर you know what you do? You gargle or you rinse your mouth, correct or not? So in that case what you are doing, why it is helping you to remove the not detergent, why it is helping you in removing the toothpaste? Because when you completely rinse your mouth with water, water is continuously moving inside your mouth. Okay, so वहां पर है ना water molecules को bond करने मिल ही नहीं रहा है, आप continuously movement दे रहे हो. So since they are not able to bond, okay, they can reach corners of your teeth and they can remove the toothpaste from your parts where it has got stuck. Okay, so this is also one of the example where we can see surface tension. Now surface energy. If I ask you a very simple question, इधर water के layers है, okay, surface energy or I would say better potential energy, more easier. Potential energy इधर ज्यादा रहेगा या इधर ज्यादा रहेगा? Lower or higher? Your answer would be higher because we have studied potential energy is related to height. So surface energy का भी almost वैसा ही concept है. Height पे जाओगे towards the surface, the energy goes on increasing. Okay, but towards the bottom the energy is less. So what we can conclude? Surface molecules. This surface molecules possess some extra energy as compared to the molecules present inside the liquid. Okay, so because of that extra surface energy, this is what is called as surface energy. Did you understand the concept of surface energy? Secondly, I also had to explain surface area. I'll give you example of raindrop. Okay, usually raindrop का shape देखोगे तो वो spherical होता है. Okay, drops usually occupy spherical shape. उसका reason क्या है? Out of so many geometrical shape that we have studied, triangle, rectangle, circle, whatever, sphere occupies minimum surface area. So everyone wants to attain stability. Okay, stability attain करने के लिए everyone will go for minimum area. Okay, so molecules will try to attain minimum surface area for their stability. Okay, and since sphere has minimum surface area, drops always try to occupy the shape of a sphere. They are always spherical in shape. So here there is a concept of change in surface area also. So इतना ध्यान में रखो, surface area decrease होगा, okay, for attaining stability, and surface energy is maximum at the top region. Okay, so this is just an introduction for our next derivation, which I am going to start. The derivation formula will be dW will be equal to P into dA. I'll explain this. dW is the small amount of work done, T surface tension, and this is change in surface area. You know, whatever work is done is stored in the form of energy. Okay, so dW के बदले बाद में हम surface energy लिखने वाले हैं. Okay, so ultimately whatever I said, ये derivation किसके related है? Surface energy, surface tension and change in area. So वो तीनों terms आ गए. Surface energy, surface tension and change in area. So let's start this. In this, I'm going to draw a diagram. It is about a rectangular frame which is dipped in a soap solution. Okay, now understand this. I'll not go very fast. एक rectangular frame है, समझो आपके पास. This is that rectangular frame like this. Okay, and इसको आप हाथ में पकड़ सकते हैं, correct? And ये rectangular frame को आपने bucket में dip किया है, जिसमें soap solution है. Okay, when you move out this rectangular frame, okay, what you will observe? Your observation will be इधर तक यहाँ पर एक soap का film आ जाएगा. Here you will find a film of soap. एक simple example दे दो. Whenever you were kids, okay, like 4th 5th standard में एक इंस्ट्रूमेंट होता है, I can't say instrument, एक खेलने की चीज जिसमें एक सर्कल होता है, उसमें एक सोप सॉल्यूशन होता है, and then we blow air, हवा मारते हैं तो bubbles निकलते हैं बहुत सारे, and we enjoy that thing. So वैसा ही कुछ है ये. Okay, instead of that circular strip, we have a rectangular frame. Okay, इसको सोप सॉल्यूशन में डिप करो तो यहाँ पर एक सोप सॉल्यूशन का लेयर आ जाएगा. Is it clear? Now let me name this as A, B, C, D. So here we have a soap solution. This is a liquid. So यहाँ पर surface tension होगा या नहीं? Definitely होगा. And as I told you, it will try to decrease its area. इसके ऊपर force act करेगा, tangential force act करेगा. So consider इधर एक force act कर रहा है, which is F. Okay, this is that tangential force जो इसको pull करेगा ये side. So because of this force, what is going to happen? इसका जो area है वो थोड़ा decrease होगा. There will be decrease in surface area. Clear with this? Let me denote this as length. This is the length of that soap film. Okay. Now we are supposed to find the formula of this F. Clear? We know P is equal to F upon L. So therefore F is equal to P into L. But there is one catch over here. ध्यान दो. एक तो हमको ये सोप फिल्म दिख रहा है ऊपर से. अगर ये रेक्टेंगुलर फिल्म को मैंने उल्टा कर दिया तो दूसरे साइड भी तो एक सोप का फिल्म रहेगा. Agreed or not? So there are two layers of soap film, one in front, another backward. So because of two layers, I will have to consider double length. Okay, so I will be writing over here into 2. Okay, why? The reason is front as well as back. Front and back. ये हो गया हमारा फोर्स का फॉर्मूला. Now what we are supposed to do? इसका एरिया थोड़ा कम हो गया है because of this force. What I'll do? मैं उतना ही फोर्स अप्लाई करता हूँ उसको वापस खींचने के लिए. Okay, I repeat. I'm going to apply an equal amount of force to pull it back outward. Okay, so understand. इधर मैंने एक फोर्स अप्लाई किया F dash. This F dash is equal to F. Okay, इसकी वजह से क्या होगा? ये फिल्म थोड़ा बाहर आ जाएगा. So let us consider this is the new position of the film. I repeat, बिकॉज ऑफ दिस फोर्स एफ डैश ये जो लेंथ है फिल्म का वो थोड़ा बाहर आ गया. ओके, सो दिस इज द न्यू पोजीशन डी डैश एंड सी डैश. दिस डिस्टेंस आई विल डिनोट एज dx. स्मॉल डिस्प्लेसमेंट समझो dx. समझ गया? ये डायग्राम कंप्लीट हो गया. ओके, नाउ इफ आई टेल यू f डैश का फॉर्मूला क्या रहेगा? What will be the formula for f dash? I have told you these two are equal, so I can write this as 2 into t into l. The same formula I can write over here. इतना समझा? हमारा लास्ट पार्ट क्या है? वर्क डन करना है. अब कॉन्सेप्ट पे आ जाओ, फिजिक्स का सिंपल कॉन्सेप्ट. इसको खींचा है मैंने, डिस्प्लेसमेंट हुआ है, सो वर्क तो करना ही पड़ा होगा. ओके, सो देयरफॉर वर्क डन इज इक्वल टू फोर्स इनटू डिस्प्लेसमेंट. So force into displacement is how much? dx. Is it clear? F dash के बदले ये फॉर्मूला डाल दो. So this will give you 2tl into dx. इतना समझा? Now try to understand one thing very interesting. This 2, this l and this dx. इसको जरा ऑब्जर्व करो. See, length. Okay, and this is acting like a breadth. Okay, length into breadth. So ये area हुआ, but let me tell you this is change in area. Why? ये original area था, बराबर, और ये extra area create हुआ है. Okay, so I can write L into dx as increase in area. Correct or not? Increase in area. Now why 2 has to be considered? फिर से इधर आ जाओ, front and back. एक एरिया आगे है और एक और एरिया पीछे भी रहेगा. So what I can write, but 2 into L into dx can be written as dA. What is dA? dA is nothing but increase in surface area. समझ में आया? So इन तीनों टर्म्स के बदले dA सब्स्टिट्यूट कर दो. So therefore dW will be equal to T into dA. I hope this matches with the first part. Okay, and as I told you, this work done can be written as surface energy also. So I will write this as surface energy is equal to T into D. So this completes our main derivation. And on basis of this derivation, we are going to solve 5 numericals today. Okay, so please take a screenshot of this. Let's start with the numerical. I'll be reading that numerical. We are going to solve numerical number 23, the last numerical in your unsolved exercise. I'm reading that numerical. I hope you have it with you. A rectangular wire frame of size 2 centimeter into 2 centimeter. So this is your original area. 23 B1. A1, which is 2 into 2 centimeter. I'll explain this with the help of diagram also. वो diagram वापस draw करता हूँ. This is our rectangular frame. Okay. ये area दिया हुआ है 2 into 2. Okay. Then dipped in soap solution, taken out. Understood? यहाँ soap solution है like this. Okay. A soap film is formed. Obviously पता है. If the size of film is changed to 3 into 3. अब समझो, इधर से 1 mm बढ़ गया. Okay, so let us consider this is now increased. So this whole area has become 3 into 3. Okay, I repeat, सिर्फ इतना सा पार्ट नहीं है, whole area has now become 3 into 3. So I'll write this as A2 is equal to 3 into 3 centimeter square. What they have asked, calculate the work done in the process. So we are supposed to find the work done, dW, and surface tension is given, which is denoted by T, 3 into 10 raised to minus 2 Newton per meter. Clear? Let's solve this. Formula, you know which one to use. Abhi just derive kiya. dW is equal to T into D. Solution. dW is equal to. Now pay attention. Please don't write. T का value है 3 into 10 raised to minus 2. This is change in area. बराबर? So final area कितना है? 9. Minus initial area कितना है? 4. So I'll write 9 minus 4. ये change in area मिला. But keep one thing in mind. ये मुझे सिर्फ front part का change in area मिला है. I hope you understood this. 9 minus 4 सिर्फ front part मिला है. Back part का भी लेने का है. So I will multiply this with 2. Okay? Back side के लिए. One more change. इसमें ना सेंटीमीटर स्क्वायर इन्वॉल्व है. Okay, subtraction centimeter square का हो रहा है. So I'll have to convert it into meter square. So I will write over here 10 raised to minus 4. I hope you understood this. Okay, value of T, change in area सिर्फ front side का मिल रहा है, back side का consider करने के लिए 2 and then centimeter square to meter square. So let's solve this. 3 into 5, 15. 15 to the 30. 10 raised to minus 2 minus 4 will give me minus 6. So 3 into 10 raised to minus 5 joule is our final answer. Okay? Yes, you can copy this right away. I'm giving you some time. It won't take much time to copy. Please. Fine. Now our next sum is a solved example number 2.5. Solved example in your textbook number 2.5. I am reading that question. Calculate the work done in blowing a soap bubble. So again we are supposed to find work done. Work done in soap bubble to a radius of 1 centimeter. So soap bubble का radius दिया हुआ है 1 centimeter and surface tension of soap solution T is given as 2.5 into 10 raised to minus 2 Newton per meter. So in this, we are again going to use this formula. We have T. What about dA? Change in area. So try to understand. Initially, soap bubble था ही नहीं, blow ही नहीं किया था. So I will write A1 is equal to 0, and finally soap bubble is blown. So A2 you can apply formula, surface area formula for bubble. They are spherical in shape. So spherical शेप के लिए सरफेस एरिया का फॉर्मूला क्या होता है 4 pi r square. Understood? But there is one catch over here. Soap bubble में कैसा है outer area as well as inner area, both areas you are supposed to consider in case of soap bubble. So two areas you are supposed to consider. So I multiply this with 2. Finally I will get 8 pi r square. Okay, I repeat, in case of soap bubble, you are supposed to consider two surface area, inner as well as outer, which will give you 8 pi r square. Let's solve this. Solution dw is equal to t का वैल्यू है 2.5 into 10 raised to minus 2. A2 is my 8 pi r square and A1 is nothing but 0. Okay, so this will give me 2.5 into 10 raised to minus 2 into 8 into 3.142 into r का वैल्यू, yes, this 1 सेंटीमीटर में है, so 10 raised to minus 2 मीटर में किया, and then this whole square. Is it clear? Now solving part I'm not going to do right now, it becomes your homework. You can quickly copy this. Okay, last answer you can very well verify it from your textbook. Solved example hai, please. We'll go for the next example, similar one from unsolved part, which you can very well try. While I'm solving, you can also solve it and verify whether you are able to do it or not. The sum number is 22. Sum number 22. How much work is required to form a bubble? So again, we are supposed to find work done. This is again a case of a bubble. Radius is given 2 centimeter. R is equal to 2 centimeter. 2 into 10 raised to minus 2 meter. Okay. From a soap solution having surface tension T is equal to 0.07 Newton per meter. So you can relate it very easily. Only values are changed. बाकी सब same है. Correct or not? So A2 will be written as 8 pi r square. Everything will be same. सिर्फ values change करता हूँ मैं इधर. Instead of 2.5, I will write as 0.07. Rest all things will remain same. Here I will write 0.078 pi. R value will get changed 2. And last answer is expected at your end. Very easy sum. Okay, please copy. Let's move on to the next sum. Please read the next sum, which is going to be sum number 20. Quite interesting sum, expected in exam. Sum number 20. Okay, so there is a particular way to solve this sum, this kind of sum. Let me give you an introduction of this kind of sum. In this kind of sum, you will be given a condition that there are lot many droplets, 27 droplets, 1000 droplets, millions of droplets. They all combine, okay, to form a single drop. And you may be asked to find the surface energy or work done. Reverse process is also possible. They may say that you have a single drop and वो floor पे गिर गया and it splitted into 1000 droplets, it got splitted into millions of droplets. So इसमें भी surface energy find करने को बोल सकते हैं. So there is a particular steps to be followed in this sum. Okay, so kindly pay attention. This sum is quite interesting. Sum number is 20. See, 27 droplets of water, each of radius 0.1 mm, coalesce into a single drop. Find the change in surface energy. So I will write over here. Here we are being said 27 droplets coalesce. I hope you must have figured out coalesce मतलब join हो रहा है, okay, to form a single drop. So जो single drop रहेगा उसका radius हम consider करेंगे capital R, and जो droplets रहेंगे उसका radius हम consider करेंगे small r. Is it clear? Then we are being given one radius. अब ये किसका radius है? Let's find out. 0.1 mm. किसका radius है ये? Droplets का. Correct? So I write this as small r is equal to 0.1 mm. This will be written as 10 raised to minus 3. Okay. Surface tension is given in the last line. Capital T is equal to 0.072 Newton per meter. Clear? Let's start this sum. So we are going to find the change in surface energy. Surface energy मतलब वही है, dW वाला ही फॉर्मूला लगाना है. Okay, so in formula section I will write as dW is equal to T into D. Okay, let's solve this. Now what you are supposed to do in this, भले droplets merge हो रहे या split हो रहे, उनका volume change नहीं होगा. Whatever volume we have for a single drop, the same volume we will have for 27 droplets. सिर्फ surface area change होता है, इतना याद रखो. Volume doesn't change. So our first step will be volume of one drop will be equal to volume of 27 droplets. Okay, volume का formula for a sphere, it is 4 by 3 pi r cube. Correct? So I will write over here 4 by 3 pi r cube, capital R, for a single drop, and for 27 droplet small r. Okay, but 27 droplets hai, so I need to multiply this by 27. Correct? One drop, 27 drop. So what all things can get cancelled? 4 by 3, 4 by 3, pi, pi. Yes, सब cancel हुआ. What we are left with? R cube is equal to 27 into R cube. अभी cube root ले लो इसका. Cube root ले लोगे तो ये बच जाएगा capital R, and this will 27 का cube root हो जाएगा 3, and this will become small r. Did you understand this? So this is first step. Okay, this method you are supposed to follow in such type of sums. Next, I will write surface energy. Surface energy is equal to T into dA. Okay, now dA is change in surface area, so I will subtract surface area of 27 droplets and single drop. I repeat, I will subtract the surface area of 27 droplets and single drop. Okay, so surface area का formula क्या है? 4 pi r square. ये volume था. This was volume. Surface area is 4 pi r square. So my next step will be T into 4 pi r square. Small r लिया मतलब ये droplet का हुआ, minus 4 pi capital R square. ये हुआ single drop का. But इधर कितने droplets हमारे पास? 27. So I will write over here 27 into. Okay, T 27 into 4 pi r square minus 4 pi r square. Now here what I will do, small r का value तो है अपने पास, correct, but capital R का value नहीं है. So what to do in that case? ये use करेंगे. This will be useful. So what I will write 27 into 4 pi r square minus 4 pi into इधर 3r put करोगे, so this will give you 9r square. Correct? T into 4 pi r square common ले सकते हैं. 4 pi r square is taken as common. Here I get 27 minus here I'll get 9. So this will give me T into 4 pi r square into 80. Fine. So now you can observe T का value है मिल जाएगा. Correct. R का value yes we have here and 18 constant, pi का value constant, 4 का value constant. So this calculation part obviously you are supposed to do it and verify the answer. Let's see whether it is matching with your textbook or not. Please you can take the screenshot of this. Okay, don't copy this, take the screenshot. Fine. Now I'm going for the next question. I'm not rubbing this because our next question is again similar to this one, quite similar. Okay. Next question is 21st. I'm reading that question. A drop of mercury of radius 0.2 centimeter is broken into 8 droplets. Change हो गया. इस बार एक single drop है and उसको 8 drops में split किया है. So I'll write reverse of this. Okay, this time I will write as one drop is getting split into 8 droplets. This sum number is 21st. Okay, what they have said, radius. See on the first line, drop ka radius diya, single drop ka radius diya. So this time we are given capital R. Okay, so capital R will be equal to 0.2 centimeter. Okay, so centimeter करना है तो I will write here 10 raised to minus 2. Convert हो गया. Find the work done. This time instead of surface energy they have written work done. So I will write dW is equal to question mark and surface tension का value दिया है. Let me write it. It is 435.5 dyne per centimeter. Okay. Done with the sum. These all things are given. You observe one thing. यहाँ गड़बड़ है. Correct or not? ये CGS unit है. So you can convert it systematically. Dyne को न्यूटन में करो तो क्या आएगा 10 raised to minus 5. Okay. सेंटीमीटर को मीटर में करो 10 raised to minus 2 and that way you can come down to Newton per meter. Otherwise एक shortcut है dyne per centimeter को न्यूटन पर मीटर में करना है तो 10 raised to minus 3. This is the shortcut. Okay, I'll write it. This can be written as 435.5 into 10 raised to minus 3 Newton per meter. Okay. Fine. Let's come back to this part. What I will write over here, volume of one drop is equal to volume of 8 droplets. This will be same. 27 के बदले आएगा 8. Okay. इधर भी आ जाएगा 8. अब क्यूब रूट लो 8 का. So this will come over here 2. Okay. So I write R is equal to 2R. Now in this sum we are given value of capital R. बराबर इसका वैल्यू है तो हमको है ना यहाँ पर स्मॉल r का सब्स्टिट्यूशन लगेगा. So therefore small r can be written as r by 2. This will be useful. ये काम आएगा. Correct. Let's come back to this part. Here instead of surface energy I will write dW is equal to T into dA. Okay. This same here 27 के बदले आएगा 8 4 pi small r square. This all things will change. ये सब चेंज हो जाएगा. Okay, let's solve this completely. T into 8 into 4 pi small r के बदले I will substitute r by 2. So that will give me r square by 4. Okay, minus 4 pi capital R square. So 4 cancel हो गया. So I am left with 8 pi R square minus 4 pi R square. So 8 minus 4, that is going to give me 4. So T into 4 pi R square. So you can easily write the values. 435.5 into 10 raised to minus 3 into 4 into 3.142 into capital R value is 0.2 into 10 raised to minus 2 the whole square, and this will give you the final answer in Joule.